Episode 226 of CppCast with guest Satabdi Das, recorded December 12th, 2019. Sponsor of this episode of CppCast is the PVS Studio team. The team promotes regular usage of static code analysis and the PVS Studio static analysis tool. And by JetBrains, makers of smart IDEs to simplify your challenging tasks and automate the routine ones. Exclusively for CppCast, JetBrains is offering a 25% discount for a yearly individual license, new or update, on the C++ tool of your choice, CLion, ReSharper C++, or AppCode. Use the coupon code JetBrains for CppCast during checkout at www.jetbrains.com. In this episode, we talk about a paper from Bjarne Stroustrup. Then we talk to Satabdi Das. Satabdi talks to us about debugging and her work on emulators and static analyzers. Welcome to episode 226 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm doing okay, Rob. Back from my trip that involved Code Dive and speaking at the Avast C++ users group in Prague and speaking at an EA special event, plus a bunch of training in Bucharest and Czechia.
Awesome.
It's a long trip.
Yeah, certainly sounds like it. We've talked about the C++ user group at Avast a couple times. That's the one Hana runs, right?
Mm-hmm. Yeah.
How was that?
That was fun. They meet, at least at the moment, I guess, yes, I think all of their meetings are at their, in their company's cafeteria, canteen, basically. So there's some free food and coffee and drinks and stuff available, and it's a pretty comfortable venue, and it was fun. Yeah.
Awesome. Well, you settled in and ready to stay in Colorado for the rest of the year, I'm guessing?
I'm hoping to.
Okay. Well, at the top of our episode, I'd like to read a piece of feedback. We got this tweet from Bowie saying, he's tweeting at both of us saying, I think exceptions and error handling would be an interesting topic for a CppCast episode. Perhaps if you had two guests to represent different perspectives on the topic. It seems like whenever exceptions turn up in my timeline and entering discussion ensues. And this is actually a reply to a tweet from Jonathan Mueller, where he was asking people, I think, if you disable exceptions, what is your reasoning for disabling exceptions?
Yeah.
Yeah, so it's certainly, we don't have too many episodes where we have like opposing viewpoints on the same episode.
I don't think we've ever done that.
Yeah, I'm not sure if we have either.
Sounds risky.
Might be. Might turn into a bit of a brawl. But we could certainly have more episodes just talking about exceptions, and I would love to have, Herb on to talk more about it when he's actually ready to like really propose that feature.
Right.
Yeah. Okay. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Satabdi Das. Satabdi has over 10 years of experience in C++. Currently, she's working on a cloud-based high-performance file system in AWS. She has previously worked on emulator, parser, and static analyzer. She's also one of the co-founders of Boston Hack and Tell, a fun meetup for programmers to showcase their work. Long back, she contributed to GNOME as an outreach intern. And not so long back, she spent 3 months at Recurse Center learning assembly, debugger internals, and distributed systems. Satabdi, welcome to the show.
Thank you. Thanks for having me here.
What is the Recurse Center?
Oh, it's an educational retreat for programmers who wants to get dramatically better at programming. It's based in New York. So they run these batches, I did the 12 weeks batch. It's a totally unstructured, self-driven way of learning. It was one of my most important, I think it was the most important programming experience I have ever had.
12 weeks. Was that full time, 12 weeks?
Yes, that's so I did 12 weeks full time because I was in between jobs. So I left my job in India. I moved to the US and I was yet to join a job here. So I did 12 weeks, but they run 6 weeks and a full week too for the people who are working. So definitely I recommend it to anybody. Like, go to it if you want to. Build something, learn something new.
It sounds like summer camp for adults or something.
Yeah, it's more like writers retreat. I mean, the creative. They do have such retreats where they like go off and then focus on their craft. It's more like that.
That kind of sound like fun.
Yeah. Do you know if it's only in New York or do they have other locations?
Yeah, it's only in New York. Okay. Yeah, you have to be in New York. So I stayed in New York for almost 3 months for this thing. So you have to be there, unfortunately.
Wow. Sounds cool, though.
Yeah, it does.
It's very cool.
Okay, well, Satabdi, we have a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about what you've been up to and debugging, okay?
Sure.
Okay, so this first one we have is Visual Studio 2019 16.4 came out, I think just earlier this week. And we got the release notes here, which is about everything in Visual Studio, not just C++. But some of the highlights for C++ are, I think this is the first version with C++ 17 complete standard library. And it's the first version that has the ASAN support, which we talked about when we had the Visual Studio team on at CppCon.
And technically, this news became out of date between the time that you put it in the show notes and now.
Oh, did they already release another update?
16.4.0 came out on December 3rd. That's the one with the major changes. 16.4.1 came out on December 10th, which appears to be a couple of small bug fixes.
Ah, okay. Yeah, they have a pretty rapid cycle. It's great. But I actually did try out upgrading to this because I wanted to see what the ASAN support was looking like. And I did have to upgrade my projects, which is one of the questions I think we had amongst ourselves. Like, could you use the C++ 15 or 17 compiler with this? And it looks like you do have to be using the 2019 compiler. So I had to make some changes to my project to get that working, and unfortunately could not fully get ASAN running yet, but I'm going to spend some more time on it. Anything else either of you wanted to call out with the new release?
Well, one thing that stands out to me is there's a bunch of CVEs at the top, security advisories, with Git for Visual Studio allowing remote execution. And it made me wonder, because I didn't get into any of these, if these are Git vulnerabilities that are affecting Visual Studio.
Or are they specific to Visual Studio?
Yeah.
Huh. Yeah, I didn't notice those. I'll have to look into them. I don't use the Git extension that much myself, though.
No, I don't. I can't not use the command line.
I actually use Git Kraken when we had them on the show a while ago. Yeah.
Oh, right.
Okay. Moving on, we have an article from Bjarne Stroustrup, a paper he sent in, and it's titled "How Can You Be So Certain?" And I guess it's him kind of criticizing the current way the C++ committee is operating. I guess he thinks maybe things are going not in a great direction. I don't know. What was your take on this article, Jason?
Well, it seems like some things are going too fast and some things are going too slow. And I don't know. There's a couple things that stood out to me. Like, where did it go? No. I'm sorry, I'm trying to find a specific passage in the document. Here we go. He says, I think we are far too slow for concepts and far too fast for the spaceship operator.
Right.
Which I really wonder, if there's just more to that story or if it's, if that's the end of it for the spaceship specifically. Right, I know Bjarne thinks we are too slow with concepts.
Yeah. I wonder what other members of the committee will think about this. I mean, obviously, Bjarne pulls a lot of weight, and I know we also covered this paper he wrote maybe a year ago, the Remember the Vasa, where he kind of brought up similar objections with we're adding too many features, things like that. Satabdi, what did you think about this paper?
so I read it. So this was pure, quite educational for me. So I really don't have any opinion on it, but it was for me a peek of what's going on, in the background. So I feel anybody who is writing C++ should read more of them. And frankly, I did not read such papers. And when you shared this link, it was really an interesting read for me. Other than that, I really don't have any other comments on this.
I do he says, he summarizes up most people's attitude, which is totally true. I hear this all the time. C++ is too complex. We need to make it smaller, simpler, and cleaner. And please add these 2 features. And whatever you do, don't break my existing code.
Yeah, that is absolutely true.
I think it is a relatively long read. So people who are listening to this might want to, there's a summary of bullet points on page 6. Where he goes over specific things and talks about how most of these things, the research for them was done in the 60s and 70s and 80s. And it's not like it's any big surprise, like concepts and contracts. But he makes this statement a couple of times in here, and he mentions operator dot, which the last time we talked about operator dot had to have been 4 or 5 years ago, Rob. It's been a while.
It may have been, yeah.
It was in the lead up to C++ 17. I'm sure of it. At best. And he says the very first extension proposal was in 1980 for an operator dot, and then he says C++ is not complete without operator dot or equivalent.
Oh, wow.
I think that is interesting coming from Bjarne, because he has, I'm sure, very strongly held opinions as to what the language needs to be complete in his mind. And if that's something that he's wanted for nearly 40 years, then yeah.
Okay. Last article where we have is actually a Git repository, and I thought this one looked kind of neat. It's called Indicators, and it is a progress bar and progress spinner library for command line apps. I just like watching this little GIF of it in action with different progress bars. I mean, it looks like you can do some cool things. It includes having a rocket ship launch from the Earth to the moon. It's pretty neat.
No, I missed that one.
The usage also is quite simple, and it feels like it should not be difficult to use this. In the README, I think somewhere in the README he has mentioned.
Yeah, I'm sorry, I'm just watching the animation.
Yeah, it certainly looks very easy to use. You just create a progress bar object, and you can have it fill up and set the color and all sorts of things. Yeah.
And you just call the tick. I think that's what is called, the tick function or something like that. Yeah, bar.tick, and then. I
don't know. I'm a sucker for anything that's pretty command line utilities, right?
Yeah.
I don't know. I just, at some point I'm going to sit down and I'm going to do some way overly complicated just console application that's got all of the things going on and remind you of IDEs from the 90s or something where everything was text based. That's, I don't know. It's fun.
Well, I'm sure this would be useful for that.
Yeah.
Okay. Well, Satabdi, you gave a talk at CppCon 2019 about debugging. And you point out in the talk that programmers spend a majority of our time debugging, but it's not something we've really talked about too much on the show or at other conference talks. So I thought maybe we'd start off by going over what your talk was about.
Yeah. So it was the talk was about how to get better at debugging, although it was named a series of unfortunate bugs, because I used a series of bugs to drive my point. What could have done better, or how can I get better at debugging? So yeah, I mean, some of these bugs were the ones which I fixed, and I jotted them down, and a couple I heard from other developer friends. We are discussing and how these interesting bugs surfaced and how they were debugged.
You mentioned unfortunate bugs that are often avoidable. How do you think we should be going about, avoiding writing more bugs?
That's $1 million question, isn't it? So I feel I somehow I came to realize this. cannot avoid bugs. It's just we can minimize the number of bugs, and we can help ourselves to debug them faster, or rather make the debugging process a little bit easier. For that, I think the standard set of guidelines apply. For example, have a set of good coding practices, talk about them, share them, and make that culture as a part of culture of your team. Do code review. Do not check in code without code review. Use tools, for example, sanitizers or static analysis tools. Use them and make them part of your regular build process. Or maybe if you can't do that, maybe if that's too costly, then do that, say, once in a week, or maybe every day after certain changes, So just have them so that you can detect the bugs faster than your customer, because it's not nice to have your customer report a bug and then try to fix, particularly in a C++ code where when you ship it to the customer, it's everything, you just strip it down. It's compiled with O3, so it's very difficult to debug from there.
So if I remember your words correctly, you said you were working on a particularly difficult bug at some point, and basically had to learn enough about the code to be able to figure out what it was supposed to be doing. Do you have any recommendations for how to quickly learn code, or how to get up to speed with this code base that you need to now be solving bugs in?
So it actually, I think a lot of it depends on how well the code was written. Like in some cases, it's really not very difficult. But in particular, in that bug's case, it was really difficult because it was a dense code. So what I would suggest is sometimes the only way, like I keep on trying a few strategies. Like sometimes you try and read the code, just without executing it. If you like, try and read and then reason out, okay, this is what is happening, and talk to other people, because I feel talking to other developers is also very important, who knows, or try to find out if there is a document. Sometimes that cannot help you. Then in that case, put it on a debugger and try and understand what's going on, what's the execution flow, or put simple print statements to verify your assumptions. Okay, this is what you're thinking, this is the execution flow, and this is the value you should be getting. Is that happening? I usually follow these three, or a mix of these three, like talking to people, debugging, using a debugger, using print statements, and then try and understand what's going on. Reading documents also.
That's it's interesting to me for you to mention, putting print statements in there, because I feel like nothing makes me want to throw my computer across the room more than when I put in these debug statements, because I cannot figure out what the code is going on, and then the debug statements never print. And I'm like, are they going to standard error? Are they being redirected to a file? Is this code not executing? And I just want to scream.
Yeah. Sometimes the code maybe, particularly if you're using printf or something like that, as bare bones as that, sometimes it does. But sometimes if you're using, I don't know whether you're referring to this, but I have seen using the existing log statements, and they're going to somewhere, and I don't know where they're going. It's a pain. It's a pain.
You're like, force it to standard out now, please. So
yes. Yeah. It's painful sometimes.
Right. You mentioned in the course of the talk, towards the end of the talk, that you, now I can't recall if you said that you actually did keep a log, or you suggest keeping a journal of your bug fixing. Can you just explain more about that?
I do recommend it. Although I usually, what I do is, if I fix something, particularly in case of debugging, if I fix something very interesting and it took me a long time to debug that, I do keep a note. Oftentimes I do not have enough times to make a good blog post out of it, which will be useful for people, because that takes effort, but I do keep a note for myself. But having said that, I do not do that for every bug. Okay. There are some bugs which are very trivial. You do not need to do that. what I did, for example, in my last job when I fixed particularly two difficult bugs. One of them I actually blogged about and then also talked at CppCon, and the other I did not. But I wrote a post-mortem statement. What was the bug? How did I find? What caused the bug? And how did I fix it? A small, very small post-mortem statement for both the bugs, and sent it to the team, shared it across the team. And I feel doing that is very valuable, although it takes time. And it's very important to have a log. Otherwise, you'll forget it. And sometimes you'll feel, okay, I may have fixed something like that. What was it? And then you forget. So I think having that is important.
Yeah, I really like that idea, because I mean, if you don't do this, otherwise the only thing you have is your git commit history, and you could spend 10 minutes on a bug and have like a one-line fix in Git, or you could spend 2 days working on a bug and it still might wind up being just a one-line fix.
Exactly.
But you should have something to say, like, here's what went into that one-line fix, to refresh your memory and everything.
Yeah, and the stories are actually very interesting. Particularly, one of the bugs that I talked about in my talk was a right shift, was an undefined behavior. And the fix was really very simple. It was one line fix, but it took me like a month, close to a month, to get to it, because it was in a code which I didn't understand. The person who wrote it left it, and it was a very well performant, he was trying to squeeze performance out of every line of that code. I don't know what, but anyway, so it's very dense spaghetti code. So the process of how did I find it, that was really interesting.
I was, when you put that up on the slide, I was immediately like, I don't trust shift operations. I know there's without any kind of checking, because I know there's undefined behavior in every direction with it, depending on signed, unsigned, whatever, and it'll overflow into the signed bit, whatever. And, but, that's almost cheating, right? Because you say, find the bug on these 5 lines of code, versus you had to find the bug in the giant code base.
Yes.
Right.
Yes.
And then I hear in that, the person in the audience answer, I'm like, I know who that was. Just enough picked up on the mic, voices that you know well and can recognize.
Yeah.
So, is this because I had just been thinking with all of the travel I've been doing lately that just taking a little bit more of a journaling attitude is not a bad idea. And then I saw your talk and you mentioned this, and I just, out of curiosity, is this part of, are you the kind of person that journals things anyhow?
Not always, not everything, but I try to. If I and this doesn't always apply to debugging, but suppose I learned something, something interesting, which I didn't know. I try to put it down. Now, I'm not very organized about it. That's one problem. Sometimes I added some stuff in my GitHub notes, but that's out of date. And then sometimes I do keep my own document in some Google Doc. So I should get more organized so that I can, quickly access them when I need to. But I need to find out ways to get organized.
You did mention blogging a couple times, and I also, if I had a difficult issue, would blog about it. But I haven't done that in a few years myself. Do you keep a public blog available?
Yes. So I wrote about both these bugs. Sometimes the problem with the blogging is, you cannot just write, here's this bug and this is how fix it. That doesn't make a very, interesting blog. Because when I write a blog, one is you always think, why are you doing it? And then also you also tend to think, what are the readers going to get from it? So that way I try to make a blog in a way so that the readers can also get something out of it. So I did write about 2 of the bugs that I covered in my talk, but they are not they're not about, this is the bug that I fixed.
Okay. I have one further question then from all of this. You said that you wrote up the idea of writing up a postmortem, and I'm curious. So, since a significant amount of the work that I actually commit is for clients, I will do this bug fix and then put the postmortem, a couple of paragraphs, basically just in the git commit log message.
Okay.
And I have no idea if that's a good idea. Basically. So that's what I'm wondering. Like, what are your thoughts on how to best communicate this postmortem to the other team members?
I think a good test of that is like after 1 year, you revisit those logs, and can you understand them? Like, probably you can, because probably you will remember them. But my point is, like, are they legible to others, or maybe our other team members are understanding from your postmortem report what happened and how did you fix it? And so that's a good test. In my opinion, like if I'm writing a postmortem, I'm actually writing it for myself, my future self, and also for team members. So that you can sort of think from that perspective.
Okay.
Starting to feel a little shame, like I'm not putting enough into my commit messages.
Yeah, you know what? It's really like sometimes it's not that I always do it. Like sometimes I'll be really ashamed of my like Git commit messages. Like, I should have added more information. But then, yeah, I mean, sometimes you're in like, oh, you know what? This is a very good commit message. You're proud of yourself. I think that's life.
You'll definitely see a difference between commit messages on clients where I'm being paid hourly or whatever, and I want to make sure I clearly communicate exactly what I did to earn the money right now, versus my own projects where sometimes it goes.
Yeah, they are the worst.
Right.
They are the worst because you're like, nobody's watching. So at least that's what plays on my mind. Like, nobody watching. So just, okay, update something, fix a bug, one-liner.
Well, technically everyone could be watching if you're doing it on a public GitHub repo, but yeah.
If it's a public GitHub, so for me personally, it's like repo I'm being paid to commit to, and then public GitHub repo, and then private GitHub repo. Who knows what those commit messages are like?
I wanted to interrupt the discussion for just a moment to talk about the sponsors of this episode of CppCast, the PVS Studio team. The team promotes the practice of writing high-quality code, as well as the methodology of static code analysis. In their blog, you'll find many articles on programming, code security, checks of open-source projects, and much more. For example, they've recently posted an article which demonstrates not in theory, but in practice, that many pull requests on GitHub related to bug fixing could have been avoided if code authors regularly use static code analysis. Speaking of which, another recent article shows how to set up regular runs of the PVS Studio Static Code Analyzer on Travis CI. Links to these publications are in the show notes for this episode. Try PVS Studio. The tool will help you find bugs and potential vulnerabilities in the code of programs written in C, C++, C#, and Java. We wanted to ask about some other stuff you've worked on too. In your bio, you mentioned an emulator platform.
Yes. So I worked in my last job. That was actually my last job. In fact, I was in that job when I gave the talk at CppCon. So it's an emulator for chip designs. So the emulator would take a chip design, which is usually represented in a high-level design language, say Verilog, system Verilog, and it would emulate the design on a custom hardware. And usually the chip design companies, they use the emulator to verify their design, or say to run, say if it's a processor, you can boot up Linux, or develop embedded software while the chip design is still going through. Their designers are still iterating on the design.
So about your emulator, so I just make sure I understand. You are emulating in software a Verilog design?
No, it's emulating in custom hardware actually.
Okay.
So you think of the FPGAs.
Yes.
So basically, you can program the FPGAs.
Okay.
So suppose you take the SoC design, which can be anything. Say a processor. And you can program the FPGAs with that design and run it. It will run much slower, meaning suppose it's the performance of the design in gigahertz or hertz. That can be like order of magnitude slower, but it would still run. And you can verify. Say, suppose, I can take a very small example. Say, suppose it's a processor and it should put up, say, Linux on it. So you can run the design on an emulator and you can boot up Linux on it. But the thing is, it will be it will be a very painful process because since the SoCs are much faster, but when you are emulating it on a FPGA or any kind of custom hardware, the speed becomes very slow. So it's really difficult to actually boot up a Linux, but it can validate your chip design that okay, it's doing what it is expected to do.
Okay.
And then the chip design companies, they have very different kind of test setups to test their chip designs.
So since I basically know nothing about this process, did you work on then software that translated the Verilog into something that could be written to FPGA?
Yes. So it has, so you can think of it as a compiler toolchain, which takes the design and transforms it. And in the end, eventually it produces a binary, which can be loaded to the FPGA. So I worked in the software. So it was written in C++, and it's on Linux because usually the chip design companies, they run this kind of verifications on Linux platform. So what I did was I worked on the scheduler part of it. Why it is a scheduler? Because any electronic design that has signals, which are some input signals and some output signals, and the signals are traversing through the design, right? You pass a signal and that something happens and some transformations happen and you get some output as a signal.
Okay.
So it's actually when you have a large design and you're loading it on an emulator, you have to partition the design because the chips on the emulator, they are much smaller in capacity than the actual design. So you cannot load a single design on a single chip on the emulator.
Okay.
So you partition actually. So that essentially is a graph partitioning problem because you can represent all these designs as a graph actually.
Okay.
So, and then when you partition the design, you have all these partitions, then the signal, there's you have to abide by certain constraints of the design, like certain timing constraints, any other kind of constraints. And there you have to schedule those signals. You can think of it as the closest example I can give to you is like a pipe system, like a complex pipe system, water is flowing. And at some certain joints of the pipe system, you're saying, okay, at this joint, the water cannot flow before the water flows from the other joint or something like that, like some timing related constraint.
Okay.
So the software part that I worked on that did all this scheduling on these graphs.
Okay. So
did I make sense? Because I always feel
so. Yes, shuffling signals between the partitioned parts of the design across chips and making sure everything has the signal when it expects to.
Yeah. So that was the very simplification, oversimplification. But essentially, if you think the software was doing that, it was taking a for me, for my day-to-day job, I was not really bothered about the hardware language or anything. My input was a graph and I was doing certain operations on the graph. That was what the tool did.
So did you, use provability of, I don't even know, some way to prove that the transformations you did on the graph were correct?
Oh, we keep on, the thing is, there are test benches, this design should work correctly. Given this input, it should produce output.
Right.
So those help you verify that the design is working correctly. So suppose if it's an AND gate, if you give 1 and 1, it should always produce 1. Or if you say 0 and 0, it should always produce 0. So those kind of there's some test suites to prove that whatever we are doing, even after we are making all these changes, the design is working fine.
So there's a test methodology I heard someone mention at NDC TechTown for the first time. I'd never heard of it before. I think they called it something like hardware in the loop testing. Mm-hmm. And so they had to have their black box, whatever it was supposed to do, and then they would feed software inputs to it and read the outputs from it. So how would you actually have to write these designs then to the hardware and then test and verify that it was doing the same output, the expected output?
You can think of it that way, when you're programming the FPGA chips actually to do what a ASIC chip is actually, because all these designs are ASIC. So you're taking a ASIC chip design and putting it on an FPGA. So you can think of it that way also. And there are quite a few different methodology of testing. Like you have a mix of software and hardware. Like you are running some model on software, and then that software is interfacing with the emulator, the hardware, and then you're getting some output. So the companies, they do, and also this my company, my ex company, they used to have this different kind of solutions for these customers to help them validate their designs.
So when you made changes on your code and committed it to the GitHub repository, did it get automatically built, pushed to a piece of hardware, and then let you know if it was doing the correct thing?
Oh, it's so the thing is,
run through some specific thing. Yeah, sorry.
So it was not actually that automated. So it was the release process was I would push some code, and we will do some verification. The QA will do some verification, and then we make a release. So that would be the software part of the release, and then that will just like Visual Studio, you're getting some release of the software, so we'll make the release and the customer will use them in their setup and then see what they're seeing.
Okay, so release validation kind of. Yes,
it was validation. It's in the domain of validation.
I'm just very curious about this kind of thing, because I've done some embedded work, but it's been a very long time, and it was always through college. I debated going and working for companies that did FPGA stuff and whatever, but never did actually do that.
It's actually called EDA. It's called Electronic Design Automation, and it's a very, very small industry riding on the back of semiconductor industry. I do not know the numbers, but and this may be like very wrong numbers, but if it's like maybe 1/6 of value of semiconductors. So it's a very small industry, and there are like very few companies. Synopsys is one of them. Cadence is one of them. Mentor, my company that I used to work in, is one of them. Now Mentor is acquired by Siemens business. So Siemens has also got into this business.
Yeah, Mentor and Siemens I've heard of.
Yeah. Synopsys, I think everybody is, more familiar because they come to CppCon, and they have acquired Coverity. So, they have the other software, purely software based business also. But all of these companies, they have solutions, in this field.
Okay. Since you just mentioned, Coverity, your bio also said that you once worked on a static analyzer.
Yes. And the static analyzer was also for hardware design. So basically, it's actually called formal verification. So you formally verify. So without running the design, you are trying to guess what are the problems. So basically, you can write some assertions, some assumptions about the design, and you're sort of trying to verify whether those are correct or wrong. So that you can think that work you can probably think pretty similar to what Coverity does for C++ code base. Essentially, it's a satisfiability solver, SAT solver. So what I worked on, not on the SAT solver part, but the transformation part, where you take the design, which is again written in some high-level language like Verilog or System Verilog, and you transform that so that in the end you get some equations which you can run to the SAT solver, put into the SAT solver, and then see whether your assumptions are correct or not.
Okay. So one other thing I want to ask you about is in your bio you said you're the co-founder of the Boston Hack and Tell. What exactly is that group, and how is it different from a programming language user group? We talk about different C++ user groups all the time.
Right. So, okay, disclosure that we ran 7 sessions last year, and this year all the co-founders have become very busy. So, and also
no.
it's a yeah, and it's a perpetual problem to get speakers for. If any of you run meetup groups, you'll understand it's very difficult to get speakers. Like every session, we will have a good 15 to 20 attendees. We will have free food, free beer, a good space, somebody would lend a space, but getting a speaker was so difficult. So it's a group where you come and you present, preferably open source project, anything that you hacked. It can be a library, it can be anything. But we prefer open source projects, and you present it. You present it for the format was you present it for 5 minutes, and then we open the floor for 5 minutes of Q&A. So we did see some very good presentations last year, but this year everybody is busy, and so maybe hopefully next year we'll again we can start it again in Boston.
Let's see. I did some training in Cambridge this year, so I'm pretty sure there are C++ developers out there, maybe even listening to this podcast. So how should they contact you if they are interested in presenting?
Oh, just join the meetup group and let us know. We would be more than happy to, at least I personally would be more than happy to start it again, because it was such a fun meetup, because people would somebody, I remember somebody presented, that person, he put a camera out of his window, and his house was on a traffic junction. So he trained the camera to detect how many cars violated the signals. It was really fun. So people do a lot of different interesting things, and I'd very much love to see such things. Just join the meetup group and say that you want to present, and we'll take it from there.
90% of cars violated the traffic signals.
So it's more of a hands-on user group compared to, just going in and discussing a topic, that type of thing? Okay.
Yeah. It's like any project you have done. It doesn't have to be as, impressive or as hands-on as this one, but anything, like any library. For example, this indicator, if somebody has written an indicator and he wants to show it to the people, they can come and then say, okay, this is what I've done.
That's fun.
Yeah.
So you mentioned several times now what company you were working for. What work are you doing now?
So right now I'm working in AWS, and I'm working on FSX for Lustre. So Lustre is a high performance file system. AWS is providing it on the cloud. So that's my day job right now.
Okay. Using C++?
No, the Lustre is written in C. And it's an open source project. And they don't use the team here. They don't use C++.
Okay.
Well, Satabdi, is there anything else you wanted to go over before we let you go today?
No, I think it is really fun talking to you two here, and also talking about emulators and parsers and static analyzers.
Okay. Well, it was great having you on the show today.
Thank you for having me.
Thank you.
Thank you.
Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/cppcast. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode was provided by podcastthemes.com. Site at cppcast.com. Theme music for this episode was provided by podcastthemes.com.